Okay, so we started this comic book one earlier. Some of the mistakes I made at first because I just was not thinking about it and hurrying. The issue number. So, like if you look on the front of a comic book, it might say issue 1. If it does, go directly to the bank and sell it. It's worth a lot of money. No, like issue 427. And often there's a letter, A, B, C type of thing. And apparently that's because there might be different covers, different artists, different covers for the same issue, right? So that's where they get the letter and so on. So I put a unique constraint on the issue number, but when I started to enter sample data, I realized, well, wait, I can't have a same issue 1A in 2 different series, right? So I had to change that unique constraint, the secondary index here for the unique comic book, to be a combination of the issue number and the series ID. Even though it's a foreign key, it can also play a role here as well, right? Well, I guess I should call that unique comic book. See, little things that I missed this morning. All right, so close that, click save, and that has actually saved that change to the name of the constraint as well. And then in the series, I did something wrong in the design here. I didn't have the date at first, and I thought, well, wait a second, there might be a whole series of Superman that started in a certain date, and I looked on Marvel and I saw that that's the way it was there. So we have a 4-character just to store the year, the starting year, date of the series, and so on and so forth. Okay, and we have the relationship as you see it up here as well between the two. So that's a starting point for us, right? So the next thing would be to make a view, right? An eagerly loaded view. So if I do a new query here, working in my comics, and with any view, as I said earlier, I start off with the query itself. So the query will be based on comic book, but all we have in the comic book table itself in terms of the foreign key here, the series, is an integer number, right? So that's why as an eagerly loaded view, we would also want to have the series table. Okay, a rule of thumb for these views is we check off everything, right? Because we need all this data, because we might need to modify it, and then anything from the lookup table. So truth is, I probably should have a nice summary field here, but I'll just make one, the name and date. Why do I need both? Well, let me run that for a second. So you see, looking here at the series names, like there's Superman 1942, Superman 1985, right? So if I just had the name, I couldn't tell them apart. But having them separate is kind of a pain in terms of building the user interface. So that's where I'm going to, well, let me get rid of some white space here. Oh, I guess I cut that word in half somehow or other. Okay. So there they are, the series name and the series date. So what I'll do is I'll concatenate them together. Maybe with a dash between, something like that. And I'll give it an alias as series, S-E-R-I-E-S. Okay. That looks better. So it has all my data, okay, the row version, the updated by, and so on. And the foreign key numbers themselves, which I have to have there, right? Plus the lookup values here. So I could think about another summary field for the comic book itself, but I'm probably good for now. So I could make this as a view just with a create view, okay? And then we would start doing all of our queries based on it. I already did this one, so that's why I'm not going to save it. So I already have that view. He's right here. I can do a select star from, and you see it's the same thing, okay? All right. Okay, so in terms of our 5 standard stored procedures, so what I did is I went to Blackboard, I grabbed my PowerPoint here on real world stored procedures, because I'm going to follow these recipes to a fair degree. So just to remind ourselves what these are all about, halfway through the PowerPoint we started into this section here on the most common stored procedures, right? They return data from a table or a view, okay? We might have more than one data selecting stored procedure in our family of standard ones. Usually we want one where we can pass in the primary key. Just give me this one record, right? often in any application, whether it's on a phone or anything else, you want to bring up a customer or a product or something like that. So you want to be able to quickly go and get it identified by the primary key. Usually there's a need for an all, right? You just give me all the data. And sometimes filtered ones. So we might have the same data always in all these selects, but we might filter it by things like the foreign key values and maybe even for text contained inside the name and so on and so forth. So they're all variations on selecting. Lookup data for drop-down lists and so on, right? We'll often create a specialized stored procedure because most drop-down lists look for two pieces of information. Whatever you want to display in the drop-down, and then an internal value that usually is the primary key, the unique identifier for a record. So sometimes just to help us populate those drop-down lists in the user interface, we'll make a stored procedure like that, right? Return a list of the primary key and a summary field. And also it's important for these to be sorted, right? Because if a drop-down list isn't sorted, you can't start typing the first letter and have it jump to it in the list. Okay, if it's not sorted, then it's very much a problem for the UI design. Now for the action queries, insert, update, and delete. Notice I'm emphasizing a record. Insert a record to update, a record to delete. So our standard procedures are usually set up to deal with one record at a time only, right? Okay. So our select with no restriction, no where clause, by a primary key value. Those are our two most important selects. And then we might do additional ones for things like foreign keys and so on, and we'll talk about that later on. And then our insert, update, and delete. Okay, the insert should return any newly generated ID values, whether it's a GUID or an identity, right? So that we can find out right away what the system gave it as an identifier. Update for version control should compare the timestamp. And also, of course, the where clause should include the identifier for the one and only record that we're updating, right? Delete, okay, if you're going to use version control there as well, which is a design decision, then you have to pass the timestamp so you can do that comparison. Okay, so we're going to use these assumptions, and I followed them for the most part in this little comic book example as well, right? Every table is an integer identity primary key. Assumption 1, we've added a timestamp field. Well, I only did it in the comic book, but we're only worrying about that table actually in our quick example here in class. And updated by and updated on audit fields are present. Okay, they have defaults if we don't supply a value, and so on and so forth. All right, I didn't bother with the created. It's the same idea. I just wanted to save typing. Okay, so our select all, right? That might be the first one we do. We want to remember to set no count on as we do that, and away we go. So I'm going to just come back here to Management Studio, and we'll make a new query window. So I'll create proc, and so my table is comic book, so user stored procedure book select all, right? There's no parameters because it just returns it all. So I'll just say as, and then my usual begin and end, right? Set no count to on, right? Because it's going to get the data anyway, so why send an extra message plugging up the network communication, right? Just to tell it how many rows were affected. And then it's just a select. So I have my view, so I'm going to do my select based on the view. Because we can treat it just like a table, it's a virtual table, right? And here's my little shortcut again. Since I'm too lazy to check them all off, I do it that way once, just selecting star. When I go back in, it automatically selects them all and lists them individually. So that's basically it, right? That's all I have to do for the first select. So I'll execute that, and that completed. So the next one would be by ID, where I'm going to pass now the primary key. So I need a parameter. So at ID int. And all I do down here, I don't touch the projection. I want the same data no matter how many variations of a select I come up with. I just add the where clause where the ID matches my parameter at ID. There we go. Number 2 down. Bada bing. Okay. You know what? While we're here, I'm going to jump forward in my slide deck to the very end. Almost the very end. Here, this one right here. Okay? Filter by foreign key. There's a bit of a programmer's trick for you, right? It's a very, very common thing. Any table that has foreign keys, like think of cities, right? It has a province lookup probably, right? Just a number, integer, something for the province. Okay, so you might want to have a list of all the cities in the system, but then be able to filter by province. So you have a drop-down list of provinces, you select a province, and you just see all the ones in New Brunswick or whatever. Well, for that kind of situation, you don't want to be choosing different stored procedures on the fly depending if you're going to filter or not. You want to be able to reuse the one stored procedure. It's much easier to set it up that way. So how do we get the stored procedure to either filter or not? Well, one of the nice and easy things we can do is take advantage of how the logic works of a Boolean expression. So if I have a parameter here for the foreign key value, again, we're going on those assumptions that, you know, primary keys are integer identities and so on and so forth, right? Then down here in the where clause, I can say where the foreign key matches my parameter, or if the parameter equals some flag value, which basically says, don't filter, right? If the flag is equal to, if the parameter is equal to this planned ahead flag value that basically says don't filter, well then that second comparison will always be true. One of the best ones to use for an integer identity is the number 0, right? Because with a normal identity, seed 1, increment 1, you'll never create 0, but it's a perfectly valid integer. So we can pass 0 as the parameter, and that basically in this case, if the foreign key matches 0, well, that's always true, right? So the OR part, if one side of an OR is always true, the whole thing is always true. If a where clause is true, then every record is included in the output. So it basically removes the filter from a logical point of view, right? So that's one way that we can set up a reusable stored procedure like that. So to do that in this case, what I'll do is I'll select by series ID. Oh. And instead of passing in the ID, we'll pass in series ID, the foreign key value, right? Where series ID matches my series ID, or the parameter series ID equals 0. That way I can pass 0 if I want it unfiltered. It's just like all. But I don't have to actually encode change which procedure I'm calling, right? So there we go. So now I have my 3 select procedures. By the way, remember they show up here in programmability. If I refresh, then I have all 3 of them right there. So that's why I'm not worried about saving them here, because I can get them back anytime I want. They're objects in my system, right? Just so you're aware, you can also do things like this. I can right click. Sure, I can script it, but I can also just say modify. If I do modify, you actually notice how it comes up as an alter. Ready for me to just run it after I make a change, right? Anyway, so that's good. So we have those. Now, let's go back to our PowerPoints for a second. So we had our all, right? And then we had our one by the primary key that just adds the where clause. And then we have our insert. Well, this is one we did it in the exercise, we had it on the test. Okay, it's the same idea. So I can use the same kind of technique to help me write it as well. Create procedure, table insert, right? Okay. So comic book insert. Now for the parameters, okay, actually this is going to be an output parameter. Nope, not series ID, just ID, right? Because we're going to output the new ID that was generated. But I have to get all of the actual parameters so I can insert the comic book, right? So to go about that, again, I can just come back here to my table, script it as an insert, and steal some of this, right? So I'll steal all this. Notice it's smart enough it doesn't make mention of the ID field because it knows that we don't change it. It's supplied by the system. Oh, before I forget, okay, off. It's the selecting stored procedures we want it on, but we don't want to suppress those messages for an action query based one. Okay. So I'm just trying to make more, it's hard to find that spot. Okay. All right. So we're going to insert into our comic book. I don't need that. And those are our fields values, so I can steal this, come up here, use it to make my parameters. Again, using my little magic Control H for the left, then for the comma spaces in that section, we'll replace it with just a space. And for the comma greater than, replace that with nothing. Strip those out. Okay. So that gives me my parameters for my comic book insert, including my output for the ID, insert into, and then I'll take this, paste it in here for values. Okay. There's a few other things we have to fix, don't worry. Replace the square bracket with our @ symbol. And then the right square bracket with nothing. Okay, so we're getting close, but, okay, a couple things. Updated on. In our recipe, we just use the getDate function. So I don't really need a parameter for that, right? So that one I can actually take out. Updated by, we want that optional because we might not, in the end with a finished product, the client application hopefully has somebody log in and you can use their user ID to know who is actually doing this update and so on, right? Inserts, updates, same idea. So for now, I'll just put null, so that makes it an optional parameter. But it does mean before I go to use it, I have to make sure, because the field itself won't allow a null. So that is where I'm going to set my @updatedBy, and this is, I could even copy it right out of the PowerPoint, equal to our isNull function, @updatedBy, and provide some value such as unknown, right? Again, the n is just because it's n varchar Unicode. Okay. Oh, I got a minus. I meant to put an equals. All right. So that deals with our updated by, and down here then we'll use updated by, but for updated on, we have to have getDate. And that finishes off the insert. So the last thing left is our usual select scope identity. I am literally copying that line of code out of the PowerPoint. Right? Since my ID is just called ID, I didn't even have to change that, where row count is 1. So that's my first standard stored procedure, and that completed successfully. Okay, now for the update, the ID, the order as you know as I do doesn't really matter, but I like to put it kind of in order. So I'll have that one first because we do have to supply that value, but it's no longer an output, right? Oh, I should be consistent, put the commas at the beginning. Okay, and the issue number, updated by, and so on. Okay, so we still have no count off. We still replace updated by with unknown, but it's no longer an insert. It's now an update. And we don't have to worry about scope identity or anything like that, right? So I'll just come over here, we'll generate an update, script table as update. And for the most part, our parameters are taken care of. So it's really just this. Oh, I'm done with that one. Okay. So just do my little replacement here. Okay. And for this stuff, there's really nothing quicker I found to get rid of it than just deleting it. Oh, of course, updated on is again get date. Okay, now the where clause, here's where we match our ID. Now, I'm going to complain because I missed that one. I forgot that, right? That's one more I have to add here. The order isn't terribly critical, but I think it happens to come here. Okay, so I think I have it right now. So we have the ID, the issue, and the row version. We set no count to off. We replace updated by with unknown if we don't have a value. And then we do the update itself. All right. Now notice we don't try to update the row version because that happens automatically. The system looks after it itself. Nothing for us to do there. Almost done. One more to go. The easiest one, okay? And that is delete. Okay, no need for extra tools. All I need here is I need the primary key and the timestamp. Those are the only two parameters I'll care about, right? The where clause will be exactly the same. It will just be a delete from, it's my table called comic book. And that is all set up then to do the deleting if the row version hasn't changed. And that's it. I've created all my stored procedures, including my extra filter one. Okay. Now, I know some students in the last section, as they created them, they wanted to write test scripts. It's good practice, and you can do it, but some of these are a little tricky because of the null parameters and so on. I didn't actually ask for a test script. In the next part of the course, you're going to be learning how to actually create an interface using these stored procedures. So I thought since we have some time left, I would quickly do that, but I'm going to stop recording first.